Hello. In the previous lecture, we had done till infinite deep square well, and we have done theory in greater detail. Uh, Now let us focus more on the problem side, because one needs to really take care of the problem section also in the examination, and one should develop that kind of approach as to how one can be uh, proficient in problem solving. So although, if you see the lectures, you would find that most of the things have been covered. So if you are well versed with the lectures that have been covered, then problem solving will not be an issue. But still, I thought it's better to now deal with separately with problems. So today I'm going to start with the problem which was asked in TFR. But let us again recapitulate on what we had done so far. So one of the important things that I taught you was to break your wave function, break the wave function, given wave function into the, or you can say as a linear combination of, as the linear combination of the eigenkets. So this is one of the important thing that you should really keep in mind. If you are able to do this, then you are able to do the problems also. Okay, so today we are going to see a few problems. So first I'll start with the TFR problem, and then we'll see the same concept being repeated in the net exam also. Okay, so let us first take the let us take a simple problem, and then we'll take the TFR problem. Okay, so the now idea is to really uh, revise all the concepts done so far using the problems. Okay, using the problems. Okay, so okay, so let us say that a particle is in deep infinite square well. So let's say a particle is in a deep uh, infinite square well, deep infinite square well, and the initial wave function given is a times sine cube pi x upon a. Then one wants to find what would be the value of psi as a function of x and t. That is, what would be the wave function at any later time t, and expectation value of x. Okay, so this is one thing that I'm going to discuss, and then I'm going to discuss shortly the question that was asked in TFR. Okay, so without wasting time, let us start solving it. Okay, so as I told you that this will not serve. So what you are going to do? You need to remember one formula. What is sine 3 theta? If you remember from your trigonometry, 3 sine theta minus 4 sine cube theta. Now what can be done? You know that what is sine cube theta? Then sine cube theta would be then equals to 3 sine theta minus sine 3 theta divided by 4. So basically now you're getting your sine 3 theta in this form. Okay. So first thing up, that what you can do, that you can write your wave function. I told you in the break, or you can write your wave function as linear combination of eigengets. So the first strategy that I taught you. So what I'll do, I'll simply write this psi at initial time, that is initial wave function, in form of eigengets. Now what I'll do, I'll simply write it as a. There would be some 3 over 4, and then there would be sine of pi x upon a. Instead of theta, you have a pi x upon a, and minus 1 upon 4 sine 3 pi x upon a. Okay, so these two things will remain as it is. Okay, now what you can do, you can multiply this by root 2 by a, and then multiply by root 2 by a. So basically what I'll do, I'll multiply by root 2 by a, and then again I'll multiply by root over a upon 2. So this root 2 upon a goes inside, then your initial wave function can be rewritten as a times, there would be root a upon 2 outside. Inside you're going to get 3 upon 4. I'll write simply it as phi 1. What is phi 1? Phi 1 is your ground state, and minus 1 upon 4, and this would be phi 3. If you remember that the corresponding eigenfunctions for the infinite deep square well was what? It is equal to root over 2 upon a sine of n pi x upon a. Okay, I hope you remember the wave function solution for the problem of infinite deep square well. So accordingly, this you get. Now it's easy to find what would be a. So it's psi star psi dx integral from 0 to a should be equals to what? 1. And this gives you what? This gives you mod of a square into a upon 2. I know that phi 1 and phi 3 are orthonormal to each other. So simply this will be 9 upon 16 plus 1 upon 16, because uh, phi 1 dot phi 3 integration would be 0, because phi 1 and phi 3 are orthonormalized. So now this should be equals to 1. And indeed it is equals to what? It is equals to, I think this a mod whole square here will turn up. Then a upon 2, this is 10, this would be 5 upon 16 simply. Okay, is equals to 1. Is equals to 1. And so you are going to get what? You're going to get a mod is equals to 4 upon root over 5. So you're getting this as a is equal to 4 upon root over 5a. So this is your normalization constant. So once normalization constant has been obtained, now we are in a position to write our wave function at any later time t. So at any later time t, our wave function would be simply what? Instead of a, we have to write this. This cancels. The 2 into 5 is 10. So this we are going to get 4 upon root 10, and then 4 is here also. So I'll write it once so that you don't get confused. 4 upon 10, and then you have this t upon 4 root 2. Sorry, this I have absorbed already. So I'll simply write. See, what I wanted to convey was, instead of a, I'm writing 4 upon root over 5a. So root a cancel. So 4 upon root 10. Okay. This is 3 upon 4, 5, 1. So 3 upon 4, 5, 1. I'm not writing 5, 1 entirely, because then it will be a lot more things here. I have a lack of space here. So I'll simply write 5, 1 only. But I'll multiply 5, 1 with the corresponding time evolution operator. So basically what I'm going to do is, oh, sorry. So this is like 5, 1, and then exponential minus iota E1 t upon h cat, and we know what is En. En, we know it is equals to n square pi square h cat square upon twice ma square. So accordingly, one can know that E1 would be simply pi square h cat square upon twice ma square. Okay, plus then again 3 upon 4, then again 1 over 4. So this 1 over 4 would come. Sorry, not sorry, minus 1 over 4. Minus 1 over 4 pi 3 into exponential minus iota E3t upon h cat. So this is what your wave function would look like at any later time t. Okay, so 4 gets cancelled. So I think if I want to really expand it in a way, so psi x comma t, that is psi as a function of both x and time, would be 1 over root 10, 3 times root 2 upon root a. So I'll simply write root a outside, 3 root 2 sine pi x upon a exponential minus iota pi square h cat square upon twice ma square, and minus this would be I think again root 2 by a, and a I've already taken outside. So even if I had taken this also outside, then also things would have been easy. But fine, this would be sine 3 pi x upon a exponential minus 9 pi square iota would come, sorry, h cat square h only, and then t upon twice ma square. Okay, so finally one can write this as psi x comma t is nothing but 1 over root 10a sorry, not root 10a. I think this would be simply root 5 in root 5a, and then you have this 3 times sine pi x upon a exponential minus iota pi square h get square, no, h get, sorry, t upon y is ma square minus sine 3 pi x upon a exponential minus iota 9 pi square h get t upon y is ma square. So this is how your wave function would look like at any later time t. Okay, so I hope it is quite a bit clear now. I hope I have not made any mistake while calculating all these things. Kindly let me know if there's any mistake. So this is one thing that's quite evident. Now, if one wants to find expectation value of x, okay, let us first find expectation value of x. And let us keep it more general. Let us try to find it as a function of time at any later instant. And we'll be finding that the expectation value of x turns out to be a constant. So let us see. So let us try to find expectation value of x as a function of time. As a function of time. Okay, so let us try to find that. So I know what is expectation value of x. Expectation value of x, because wave function is real, so psi star is simply psi only. So even if you write it as, I'll directly write it. Okay, so I hope this much of thing I can directly write. I hope this is quite clear. Now, what would be psi mod whole square? So it is psi star into psi, and I already know I have what? I have this 1 over root 10, and then I have this 3 times pi 1 exponential minus iota even t upon h get, and then minus pi 3, and this I had, I think, exponential minus iota e3 t upon h get. I think this was it. Okay, now what is psi star psi? So this is psi. Now we want to find psi mod whole square, and which would be certainly 1 upon 10. This, see, whenever you multiply psi star with psi, so psi star would give you what? Exponential iota even t upon h get. So psi star would be corresponding to exponential iota. So what I want to convey is that if you are finding psi star would be, all these things will remain same. The only thing that would change is this time dependent factor. So this will become positive. Okay, I hope this much of calculations you can do on your own. Just thought to elaborate on this. So what will happen that, because phi 1 and phi 3 are orthonormal, but now because this time factor remains, so one needs to be very careful. But anyway, phi 1 when goes with phi 1, that is psi star and psi, when phi 1 multiplies with phi 1, that would be fine. That would be like this thing, 9 phi 1 square, simply because exponential minus iota even t upon h get, and then exponential iota even t upon h get, this cancels. Then plus simply pi 3 whole square. Okay, now what remains to be seen is the cross terms. You have to be really very careful here. Otherwise, there could be there one can really make a mistake here. So this will be this will be 3. I think this would be a negative here. I think minus. Okay, 3 phi 1 phi 3, and exponential. You have this iota E3 minus E1 h get, sorry, t upon h get, this is 1, and then cross term, this one, this term. So this will be again minus 3 pi 3 phi 1 exponential iota E1 minus E3 t upon h get. So I think this is clear. Now what I will do, I'll simply write it as psi mod whole square. This would be 1 upon 10. You have this 9 times phi 1 square plus phi3 square. If I just take 3 common out and even phi1, phi3 common out, what I'm getting? I'm getting exponential. If I say this is theta, so this will be minus theta. So e की power iota theta plus e की power minus iota theta is what? It is 2 times cos theta. And cos is even function, whether you write uh, E1 minus E3 or you write E3 minus E1, it is one and the same thing. I hope till now everything is clear. Okay, so finally, now I can write my psi mod whole square simply as 1 upon 10, 9 times phi 1 square plus phi 3 square minus, this need to be taken care of. I think 3 into 2 is 6, phi 1, phi 3 cos E3 minus E1 t upon h get. So this you have to remember. See, whenever you have a mix, whenever your wave function is a mix, is admixture of two states, then your psi mod whole square may depend on time. So you have to be very careful. If your psi is a eigenfunction, then it will not psi mod whole square will not depend upon time. If psi is some eigenfunction, let's say if I'm saying psi is purely phi n, then I know that at any later time it will be phi n exponential minus iota e n t upon h get. And now if I try to find psi mod whole square, it will not depend upon time. But if your psi is admixture of two states, let's say here there are only two states, then this time dependent factor may crop up. So you have to be very careful. At times people make mistake here, so that's why I'm focusing here. Now, so at the end of the day, we wanted to find expectation value of x, and that was what? That was simply integrating from 0 to a x, and then you had this 9 by 10 phi 1 square dx plus x integration from 0 to a phi 3 whole square upon 10 dx minus simply 3 upon 5 integration from 0 to a phi 1 phi 3, and then you have this cos factor as well. But cos anyway, it is a time dependent factor, and we are integrating with respect to x, so this I can take out clearly, but let it be for right now, let it be here only. So now, and then you have to know that this is what? This is 9 upon 10. If you remember, this is x into phi 1 mod phi 1 square. So basically it is equal to what? It is equal to expectation value of x, expectation value fx for this, for the state, for the ground state. And we know that we've already found that expectation value of x remains equal to a upon 2 for stationary state phi n. So for any stationary state phi n, we have already calculated that expectation value of x is equals to a upon 2. So simply I can write here 9 upon 10 into a upon 2. So I'll write it later on. This is expectation value of x corresponding to 1 upon 10. Expectation value of x corresponding to the eigenstate. I mean, this is the for the eigenstate phi 3. And then we have this thing. So here we have to be very careful. So cost term I'm taking out because this is dependent upon time. So we don't have to integrate with respect to time. We have to integrate with respect to x. And I know what is phi 1 phi 3. So from 0 to a, phi 1 phi 3 would be 2 upon a. So outside you will have a 2 over a. And then you have the sine of, I'll prefer to put 2 inside. So sine of pi x upon a into sine of 3 pi x upon a dx. So this will be 1. And then you have this thing. So this is equals to 9 upon 10. Expectation value of x for the stationary state phi 1. It is simply a upon 2. And here also it will be a upon 2. This is something that we have already done in our previous lectures. So I'm not redoing it. So I'm directly using the result. Minus 3 upon 5. And then there is some cost dependent term. So I'm writing this time dependent term, not cost dependent. So there's a time dependent term. This I have written. And then you have this thing. If you remember, what is 2 sine A sine B? It is cos a minus b minus cos of a plus b. So this will be cos 2 pi x upon a minus cos of 4 pi x upon a. And you know that when cos integrates, it gives sine. When cos integrates, it gives sine. Okay, so I'm going to hint you all other thing you'll do on your own. So if cos integrates, it gives sine. And if you place the upper limit, it would be sine 2 pi, sine 2 pi is 0, lower limit sine 0. Similarly, here also sine 4 pi is 0 and sine 0 is 0. So I want to convey that this integration would go towards 0. So I'm not bothered about it. So expectation value of x finally turns out to be a by 2, 9 upon 10 plus 1 upon 10. So this is how you do your question. So here expectation value of expectation value of x or expectation value of position operator does not depend upon time, and it is also a constant. So I just wanted to convey that whenever you have these kind of things, that is whenever your wave function is written in form of sine and theta or cos and theta, the idea is to replace in linear combination of some sines and cosines. You have to do a little bit of trigonometry. You have to replace this in the linear combination of sines or cosines, something like this. So that then things will become easy. Okay. General rule initially, if a wave function is supplied, try to write that wave function in form of eigenkets. Then things will become really easy. So this is what I wanted to convey. And now let us do a example problem from your TIFR exam. So that with this theory, from this example itself, I wanted to convey that. But now with this theory, that I've already developed. Now we are going to see a question that has been asked in TIFR exam. Okay, so this was asked in TIFR exam. Okay, so in TIFR, this question was asked. This question was asked in TIFR 2015. I hope screen is visible, and I don't. So even if I hope this question is visible. 1,000 neutral spinless particles. So spinless means the spin is 0. So these are bosons. So we are not going to follow any Fermi-Dirac statistics. Are confined in one-dimensional box of length 100 nanometers. So length is what? 100 nanometers. Or simply A I should write. Okay. So whenever in exam you are getting a problem, don't keep seeing that particular problem. Try, even if you're, any day, if you're writing exam, obviously, just by looking at questions, you won't be able to do it, right? So what is the way ahead? Whatever little bit is given and whatever little bit you are aware, just start jotting down those data at least. This is one of the ways in which I also do these problems, and I've done my problems this way only. That let's say even if I don't have any idea, clue of this particular problem, what I'll do, I'll start jotting down the relevant data, and I would start writing relevant stuff. So for example, if one-dimensional box has been given, and so I know that the wave function corresponding to this particular quantum mechanical problem would be simply root 2 upon a sine of n pi x upon a. This is something that's clear. And you may say that why you are thinking of infinite deep potential? Well, because the word is confined. So confined means what? The particle is not allowed to go outside this box. So it gives me an indication that the potential here would be infinite. So this is how you do a problem. Okay, this is how you do a problem. Otherwise, every time you'll approach a problem and then you'll get confused. So start writing down meaningful stuff. So another meaningful stuff is that energy eigenvalue corresponding to this problem of infinite deep square well is n square pi square hkt square upon twice ma square. Okay. Now, number of particles given is 1,000. 100 of these particles have energy 4 epsilon naught, and 900 have 225 epsilon naught. Now, if you see, this has been deliberately given. See, by 225 is square of 15, 4 is a square of 2. So you know from your evaluation that we've already done that your energy is n square times some constant only, and that constant is the ground state energy. Okay, instead of ground state energy, they have given this as epsilon naught. So obviously they have concealed the data, but they have not concealed it entirely. They have given you quite good amount of hint that out of these 1,000 particles, 100 particles are possessing energy what? Are possessing energy 4 epsilon naught, which implies that they must be in the state psi 2 or phi 2, whatever suits you. And 900 particles are having energy what? Are having energy 225 epsilon naught, which clearly indicates that they must be in the state 515. So one thing is quite clear. If I want to prepare my wave function initially, I can prepare in the form of what? I can write it simply phi 2 and some plus 515. Now question arises, what would be the constants? I mean, what would be the coefficient? Now really see 1,000 particles out of that 100 particles. So what is the probability of finding the particle in state 2? That is, I mean, what is the probability of getting an energy measurement as 4 epsilon naught? It would be 100 upon 1,000. And what is the probability that we get a measurement of 225 epsilon naught? It would be 900 divided by 1,000. I hope this is quite clear. And this is what? This is C15 mod whole square. And this would be C2 mod whole square, right? So if I'm writing here C2, if I'm writing C15, now it is quite evident that your C2 would be simply 1 over root 10. And then this would be phi 2. And what would be C15? C15 would be 3 upon root 10. And this is phi 15. So wave function, if I want to prepare, the wave function initially would be in this manner. I hope it is clear now. Okay, I hope it is clear. Now the question, let us read. Then the number of the particles in the left half of the box. So now the question asks that on the left half of the box, how many particles would be there? Okay, so let us try to do this particular problem. Now, see, initially what I did was in the model problem, I found the expectation value of x. Okay, now the question here is not expectation value of x. They're asking you, what is the probability of finding the particle in the left half of the box? So we have to find the probability of finding the particle in the left half of the box. So basically, what would be probability? Probability would be 0 to integration 0 to a by 2 psi mod whole square dx. This is what is the probability of finding the particle in the left half of the box. And once we know the probability, and then we know that total number of particles are 1,000, then we would be able to know that how many number of particles are there in the left half of the box. Okay, I read the question wrongly. Question has been asked that number of particles in the left half of the box. So my idea is that I will find what is the probability of finding the particle in the left half of the box. And once I know that the probability is, let's say 1 over 10, then I would be saying that, okay, 100 particles are present here. Okay, so this is how I'm going to do. So first, let us find the probability of finding the particle in the left half of the box. Okay. So let us find the probability of finding the particle in the left half of the box. So what would be psi mod whole square? So if I want to add a time dependent term, that also I can do. So psi at any later time x comma at any later time t would be what? 1 over root 10 phi 2. There would be some exponential minus iota e to t upon h cat plus 3 over root 10 phi 5 exponential minus iota t15 t upon h cat. So these remains. I'm not saying that. Okay. So this is at any later times t. So this will give you 0 to a by 2. Now we have to really pay attention. Now it is not 0 to a, it is 0 to a by 2. So one needs to keep that caution. This will be phi 10, 1 upon 10 phi 2 whole square plus 9 upon 10 phi 5 whole square. This is fine. Then you will have this thing. I mean, this cross terms would be there. So cross terms we have to see. So 1 over root 10, 1 upon 10, pi 2 whole square, no, pi 2. So I'll write it once so that we are not getting confused then. So let me just once write it somewhere. So here I'm doing, okay, let me do it here. So this is 1 over root 10, pi 2, exponential, first phi star I'm writing, okay, phi, sorry, psi star and then psi, okay. So this is E1 t upon h cat plus 3 upon root 15, root 10, sorry, 5, 15, this is not 5, 5, my bad. This is 515, okay. 515 star, I should write star here, star is conjugate, exponential iota, E15 t upon h cat. Now, if I multiply it with what? If I multiply this by 1 upon root 10, phi 2 exponential minus iota E1 t upon h cat, and then you have this plus 3 upon root 10, you have 515 exponential minus iota E15 t upon h cat. So what you're going to get? You're going to get C. So this is psi mod whole square. So this term and this term gives you 1 upon 10 phi 2 square. This I have written here. Okay, I should write phi 2 mod square, but already see, I know that for infinite deep square, well, your phi 2 and phi 5 are real. So whether I write mod whole square or whether I simply write phi 2 square, these are one and the same thing. Now let us think about the cross term. So cross term would be 1 upon root 10 and 3 upon root 10. So simply 3 upon 10. This will give you phi 2 star. I'm not writing phi 2 now. Phi 2 star 515. And this will be exponential iota E15 minus, this is not 1, this is 2. Making some silly errors here and there. So this is E2. This is also E2. Okay. So E15 minus E2 t upon h cat, and then again plus t upon 10, 515, phi 2, exponential iota E2 minus E15 t upon h cat. I think this is something that we've already done. Okay. Now integral dx. Okay. So now this would be probability of finding the particle in the left half of the box is 0 to a by 2. You will get 1 upon 10 pi 2 mod whole square plus 9 upon 10 pi 5 mod whole square. And then you have this entire thing. What should I write? 3 by 10, 3 by 10 is common. So I'll write simply 3 upon 10. And exponential, again, same story. These two when added will give you 2 times cos theta. So this is 6 upon 10 cos of E15 minus E2 t upon h cat. And then the entire stuff that is phi to 515. Now phi to 515 will not be equal to what? This will not be equal to 0. Okay, integral is from 0 to a by 2, and then there is a time dependent. So you have to really think about this. Okay, so you have to really think about this, and at any given instant of time it is given. Okay, so at any given of, and then the number of particles in the left half of the box will be approximately, okay, approximately equal to what? So let us see what answers we get. If I integrate it, so probability would be simply integration from 0 to a by 2, 1 upon 10. This is 2 upon a sine square 2 pi x upon a dx plus 9 upon 10 into 2 upon a integration from 0 to a by 2. This is 515. Why I'm not writing it rightly? This would be sine square 15 pi x upon a dx, and then plus plus 6/10 cos, and this stuff would be E15 is what? It is 220. I'm not writing it anyway. This we'll write if we feel like that this term is really that important, then we'll write, otherwise let it be. An integration from 0 to a/2. And I'll take 2 common from here. So I'll take 2 common, so this will be 3. And here I'm writing 2 times sine of 15 pi x upon a into sine of 2 pi x upon a. Okay. Okay, now let us see what this integration will get. Simply, probability of finding the particle would be 1/10 integration from 0 to a/2. And what it will be? It will be simply 2/a gets outside. So I'm writing here 1 minus cos of 4 pi x. In fact, I'll not take it. So 2 sine square theta is 1 minus cos 2 theta. And then plus 9/10 into 1/a. And then this integration from 0 to a/2, you'll get 1 minus cos of 13. Okay. And this cross integration would be 3/10. This cos some E15 minus E1 t upon h get, and then you have this entire term. So integrations from 0 to a/2. 2 sine a sine b is cos a minus b. So cos a minus b, that would be sine 13 pi x upon a minus cos a plus b. Okay. Now, see, this integration would become x. Cos integration is sine, and I'm just writing it here. I'm just indicating that it would be sine 4 pi x upon a. Obviously, some constants would be there. I'm not denying that. Divide by 4 pi upon a would be there. I'm not denying that. I'm just trying to make a point that if you integrate, you place a/2 here, it would be sine 2 pi. And similarly, if I place here also a/2, it would be 0. I mean, integration would be what? It would be sine of 30 pi x upon a. So if I place at x a/2, it would be sine 15 pi. And if you place the lower limits, it would be simply sine 0 and sine 0. So therefore, I'm not going to write all these things. I'm directly going to write it as this integration as 0. So this will be 1/10. This is 1/a into this a/2. Similarly, this also plus 9/10 into 1/a into a/2. I hope it is clear. Plus 3/10. And this cos integration would be there. So this is E15 minus E1 t upon h get. And then this integration like cos is sine. So a upon 13 pi sine 13 pi x upon a minus a upon 17 pi sine of 17 pi x upon a. Okay, so this integration from 0 to a/2. Okay, at 0, this would be 0. So I'm not bothered about that. So the probability will be a function of time, obviously. So probability will be a function of time. And it will be like, this is, let us say, a cancels a. So this will be 1/20 plus, I think this is 9/20. Okay, plus this very unusual term that is 3/10. And then you have this cos E15 minus E1 t upon h get. Okay, and then this particular term, this particular term would be a upon 13 pi, because see, if you place a/2, so it will be sine 13 pi/2. And what is sine 13 pi/2? Sine 13 pi by 2 is sine of 6 pi plus pi by 2. Sine of 6 pi plus pi by 2 would be simply 1. And similarly, sine 17 pi by 2. What is 17 pi by 2? It is sine 8 pi plus pi by 2. So I'm simply writing it as 1. Okay, 17 pi. Okay, so probability of finding the particle on the left half of the box would be 1 upon 10 plus 3 upon 10, and then this value, that is, I think this would be 4. What should I write? I should write simply pi. Then I should write a. I think this a I have missed somewhere. A, my mistake. Okay, a would be here. C. If you see. Okay, so if I'm writing this, no, so a should come. I think I've made a mistake somewhere or what. 3 upon 10. Okay, and then 2. Okay, so I've written, so a I've forgotten to write here. So a. Okay, anyway, this a would come. So a cancels out a. So this would be 3 upon 10, 4 pi divided by 17 into 13 into pi square. And then you have something like cos term added to it. So cos 15, cos of bracket में E15 minus E2 times T upon H. I'm again and again writing this as E1, why I don't know. This is E2, okay. So probability of finding the particle on the left half of the box is slightly greater than 0.5. Because see, this would be 1 by 10 plus 9 by 10. It was, I think, 1 by 10, 9. It was, I think, 1 by 20 plus 9 by 20, sorry, 1 by 20 plus 9 by 20. So 1 by 20 plus 9 by 20 is what? This is 1 upon 10 upon 20. This is, so this is, I would write, so probability of finding the particle on the left half of the box at any later time t, would be simply 1 upon 2 plus this time dependent term, which is very complicated right now. It seems it is equals to 12 pi divided by 17 into then 13 into 10 divided by pi square. Okay, and then this cos term is there. T upon H. Okay, so approximately, if I am to approximate, approximately it would be close to 500 only, because see, this term anyway, see, cos anyway remains between -1 to +1 only. Okay, so if these values are supplied, cos remains between -1 to +1. -1 to +1. If I take the maximum value also 1, and if I take the minimum value also -1, it is not going to create much difference, because this particular thing is around what? So cos maximum to minimum is what? -1 to +1. So probability can fluctuate between, I'm just writing, probability can fluctuate between 1 upon 2 minus of, I think this would be 12 upon 17 into 13 into 10, and then this pen, I don't know why there's a problem. Then this would be pi, and then 1 upon 2 plus 12 divided by 17 into 13 into 10 into pi. So if I'm to really find what this particular value is, let me just see what this value would come, and then I'll let you know. So this value, let me calculate. Just give me a minute. So this is like 12 divided by 17. This should not be 13. I think this is something wrong. No, 13 here. Okay. Divided by 13, and then divided by 10 again, and then divided by pi also. So this value turns out to be very close to 0.0017. Okay. So again, if let me just calculate it once again. If I've made a mistake, then we'll have to see. 3 upon 10 is fine. 3 upon 10, because see, 2 I have already absorbed inside. So what I have done, when I calculated these cross terms, so this was 3 upon root 10, this was 1 upon root 10, this was 3 upon 10, and then cross terms 5, 2 and 5, 15 root 2 upon a would come, so this would be 6 upon 10 anyway. Yeah, I hope this is, yeah, I'm not making any mistake. Even if I'm making, what I want to convey that, because see, probability fluctuates with time here, okay? With respect to time, it is fluctuating. But what maximum it can fluctuate? +1. Sorry, cos can fluctuate to the maximum of +1 and from minor, because cos is an oscillating function and it remains between -1 to +1. So this is, I think, something that you know. So this is 0.00. I think again, if I'm calculating, so I hope the concept is clear now. So just calculation part, I'm redoing it so that you don't get confused. This is 12 divided by 17 divided by 12 divided by 17 divided by 13 divided by 10 and then divided by 5. So it is 0.00172. Okay, so this is one fine. And the probability of finding the particle. Okay, and that was what? I think from 0 to a by 2 integral now. Okay, that portion I've taken care of. And this is 1 by 2 minus 0.00172. So on this side, it is around 4.998. And around this side, it is, just let me write, it is around 5.0017. Okay. So probability of finding the particle in the left half of the box is lying between 4.998 to 5.0017. So there are 1,000 spinless particle. Okay. So how many particle can be approximately present? Okay. How many particles can be approximately present in the left half of the box? A tentative idea is around 499.8 to 500.17. So approximately, I would say that on the left half of the box, approximately 500 particles are present. So this solves your TIFR problem that was asked in 2015. I hope we're going to see all these kind of problems in our sessions now. And now I'm going to cover this infinite deep potential well through problem solving. Okay, so much of theory has been done. But I would really suggest that you have to really take care of the theory. Time and again, you have to read it. You have to go through those lectures so that problem solving becomes easy for you. I hope to meet you in the next lecture. Till then, take care. Bye-bye.